We're going to start this unit with a review of the properties of exponents that you should have learned in Algebra 1. This will be a good review to prepare you for polynomial functions in the upcoming unit. So just a quick recap of what an exponent is and talk about the different parts. So if we have a 2 being raised to the third power, the 2 in this case is what we call a base, and the exponent is what we call the power. Now, a lot of the properties will have something to do with one of the two, either the power or the base, and so you'll need to be able to identify those parts. Now, we have this concept summary, this box for property of exponents. So it would be good to keep with you as you work through example problems so that you can refer to it as necessary. Now, we will use these in quite a few things throughout the rest of the year, so make sure you know these very well. We're going to start with these properties of exponents just using numerical expressions like 2 to the third. And the next part of the lesson, we'll go to algebraic expressions, which would be something like x to the third, where x is the base, and of course 3 is still the power. So we have numerical expressions and algebraic expressions. So we'll start applying these properties to numerical expressions. So let's take a look at this first one. Part A is a power property, where we have a power being raised to a power, so that is multiplication. Whenever you're doing numerical properties, make sure you use your calculator effectively and you work it all the way down to a final simplified answer. And if that requires reducing fractions, you need to do that as well. So don't just stop with the exponent property. Make sure you finish the problem as well. In part B, we see a property that is very important that you understand. The 2 basically is being applied to both the numerator and the denominator of the particular fraction that's being raised to the power. Lastly, if you have a negative power, remember that that's the same as writing it 1 over the positive power, so very important property to remember there. Now, a lot of the expressions that we're going to deal with are not going to be just single properties. They're going to be multiple properties layered together, where you have to recognize a number of things that are going on. So go ahead and take a little time here on sample problem 1 to work A, B, and C, and then come back and check the solutions. Alright, so for part A, we're just going to go ahead and work this. So we have a power being raised to a power, so we're going to multiply the 4 and the 2, which gives us 3 to the 8th power. Now, you should not stop at this point. Would prefer you to move on and go ahead and raise 3 to the 8th power. If you're looking at your calculator, that should be 3, and then of course you're going to use this little caret symbol, and then the 8, and that's basically how you do 3 to the 8th power, which should equal to 6,561, and so that would be your final simplified expression. Let's try part B. So we raise both parts to the third power, 5 to the third and 8 to the third, which is going to leave us 125 over 512. If you get a big fraction like this, you should probably punch that in your calculator just to double check to see if it can be reduced. In this case, it cannot, so we'll do that. Now, here's one where we have two parts being multiplied. Now you could do this, you could approach this one of a couple ways. Since the negative 2's are the same base, what happens here is we can actually take that and take the exponents and add them together. And so that would simply leave us negative 2 to the 6th power. And make sure that when you do this in your calculator that negative 2 is in parentheses when you raise it to the 6th power to get 64. Now, if we wanted another method, the negative 2 power being raised to a negative exponent could actually be put over underneath and to make it a positive exponent. And then what's going to differ here is, since we have the same base through division, we will subtract these, and so that's going to be 9 minus 3, which is still going to give us negative 2 to the 6th power, which is 64. So you can just see two ways to work the same problem. And so in the next part of this lesson, when we get into algebraic expressions, having both methods may help at some point in time. Now we'll take a look at exponent properties dealing with algebraic expressions. So this is a situation where we could have variables involved. And I want to just kind of remind you of what you're really dealing with here. Let's say that I have x to the third power. What you're really dealing with, if you factored that, that's the same thing as x times x times x. And of course, all of these are understood to be to the first power. So if you got in a situation where you were unsure, let's say of x to the third over x squared, and you were unsure of the property to deal with the exponents, you could always kind of use this factoring process as a bailout. So if you did x times x times x, and that was over the top of x times x, what you could simply do is you could cancel out the terms that were same on top and bottom. So this x and this x can cancel out, and this x could cancel out, and so that would leave you just an x to the first power as the answer. Now, the reason that we can cancel these top and bottom terms is because they're being multiplied together. So if they were being added together, you cannot do that. So remember, in its simplest form, a base being raised to a power is just how many multiples of that value that we have. So you can see here, part A and B, a couple of examples. You can see that these things can get layered up very quickly and they become very complex. What you really need to do is break this down into one simple property at a time. Take care of something that you recognize, rewrite it, and then adjust from there, and then go to the next property until you have it broken down as far as you can. So let's move on to sample problem number 2, and let's take a look at some examples here. You have A and B on this page, and then on the next page you have C and D. So go ahead and pause the video at this point and try to work those problems, and then come back and look at the solutions. Okay, so we'll start with part A. We're going to start by distributing the power of 3. So that's going to make this a to the 6th power over b to the negative 9th power. Now these aren't same bases, so we really can't do anything with the exponents here. However, we should never leave an exponent as a negative power. So we want to go ahead and change that to a positive by bringing it up above into the numerator. Alright, and that's the simplified form of that problem. Now, in part B, we have a whole bunch of y's going on here. This can be a little tricky with the negative y, but let's go ahead and take care of the exponents first. Negative y squared to the 5th power is going to give us negative y to the 10th power, y to the 2nd power, and y to the negative 12th power. Now, this negative y to the 10th power, the negative y is not the same base as the other y's. So what we really want to do is we want to factor out a negative 1 from there. So we can really write that as negative 1 times y to the 10th times y squared times y to the negative 12th. Now, we have y's with the same base, so we can add up all of their exponents. So I'm going to have y, and it's going to be 10 plus 2 plus a negative 12, which is basically just subtracting 12, which is going to give us negative 1 y to the 0 power. Now, those of you who did not see this and can't recall, anything to the 0 power is just equal to 1, and that's part of your exponent properties in your concept summary. And so this is going to be negative 1 times 1. So anything to the 0 power is just a positive 1, and then we have negative 1 as our simplified answer. So you can see that sometimes you'll get an expression with a ton of variables in it that could reduce or simplify down to just a numerical value. So be aware of that. Now we got a couple of others. So starting to layer on and get a little bit more complex. And so this is where we want to just take one property at a time and apply it one simple step at a time. And so what we're going to do here is the top, we're going to just go ahead and distribute the power of a power. Now remember that squared has to go both to the x and to the y because they're both inside the parentheses. So that's going to leave me x squared and y to the 4th with x to the 3rd and y to the negative 1. Now, anytime you're dealing with division, I like to think of it as with two different variables as just being really broken apart. You can really deal with the x's by themselves, and you can deal with the y's by themselves. So the x's have the same base, and division is subtraction, and that's going to be the y's are the same base, so it's subtraction again, and then that's going to be x to the negative 1 times y to the 5th power. And of course, x to the negative 1 should be written as 1 over x to the 1st power. And then when we finish this, we simply have y to the 5th over x as our final reduced term. Now, if you look at it, maybe a little easier way to do this. You could look at the top and the bottom, and here with the x's we have positive exponents. So we have 2 on top, 3 on bottom. If I were canceling out x's, I have one more x on bottom than I have on top. So really you could see that the x is going to be left on the bottom in the long run. So if you think of it that way, maybe an easier method for you. Alright, let's go to part D. So I've got r times s squared, and then I have a power of a power, so now I have r to the 3rd power and s to the negative 3. Now if you really want to look at this, I could maybe look at this in a different way. I could say that this is times s squared, and if I want to change this negative 3 to a positive, I could either do 2 minus a negative 3, or I could just simply move this up and make that a positive on the top side. Now, keep in mind this is r to the 1st power, so if I really want to kind of shortcut this, I could say, well, there's 1 r on top and 3 r's on bottom, so there's 2 more on bottom. So that's going to leave me 5 s's on top, 2 r's on bottom, and I could really use that as a little bit of a shortcut without having to go through the full property. So there you've seen a couple different ways to apply the properties. You need to find the way that you understand the properties and how they're applied best, and how you can best be consistent with them.